Hi everyone, in this lecture I'm going to show you how you can solve a problem using STL. So what we are going to do, we are going to solve a problem called Indian money change. So in this problem you are given Indian currency. For example, the Indian coins are of this form. So you have a 1 rupee coin, 2 rupee coin, 5 rupee coin, 10 rupee coin, 20, 50, 100 rupee note, 200 rupee note, 500 rupee note, and 1000 rupee note or 2000 rupee note. Okay, so question is given amount of money, let's say 168 rupees. You want to find out a way to make the change by using minimum number of coins. Okay, so how do you make a change for rupees 168 in the Indian currency system? That's what it is given. So the algorithm is very simple. The algorithm is, you will first look at the coin that offers you the highest value, and that is less than 168. So clearly in this case, this coin is 100 rupee. Okay, so we'll say, okay, I will first subtract 100. I will be left with 68 rupees. From 68 I will choose the largest coin that is less than 68, that is 50. So I'm left with 18 rupees. I can say, okay, look for a coin that is less than 18. So clearly I have 10 rupees, and so on. Okay, so clearly we want to find a number that is uh, close to this number from this array. Okay, so one way is you use linear search, another way is you use binary search, and we are going to obviously use binary search because this is a sorted array, and we will take help of lower bound function. And it is also possible we might need to write our own comparator. Okay, so maybe we will write our own comparator if needed. So what I can do, I can actually use upper bound function. Okay, so if I say I want to find a lower bound for 100, I will get this particular index. And if I say I want to find a lower bound for 120, I will actually get 200. Okay, so this is something that we want to avoid. Okay, we want to avoid this thing. So for 120 we should get the number as 100. We should get one smaller number. So maybe let's try to use lower bound function first. So I can say int lower bound of, let's say, 168. So lower bound of 168 should be 100, but as we know, the current lower bound function gives me something that is greater than equal to 168. Okay, so what we will do, we will use a comparator and we will reverse the comparison. We will say, okay, give me something that is less than equal to, okay, that is less than equal to 168. So what I can do, I can say int lower bound equals to uh, lower bound in the coins array, and coins plus n, where n is the size of the array. Okay, so n will be equal to size of coins upon size of int. So basically why I'm teaching this is because I want to show you how you can use comparators with binary search. Okay, so that's the whole idea of taking this problem. So let me show you. If you just do coins plus n, and if you give money, and if you subtract the base address from this, what you get in lower bound. Let's see just for this case. Then once we have sorted this lower bound function, we can just put entire thing in the loop. Okay, so we are getting the 7th index, and we can say, okay, whatever is the value at this 7th index, that is coins of LB, that we can see. So we are getting 200. So clearly, as I said, a lower bound of 168 will give you 200, but we actually want 100. Okay, Indian coin change .cpp. So how do we fix this? So one way is, okay, let's do one thing. Let's subtract this index 1. So in this case, we will get 100 as the answer. Okay, but suppose if I give 100, then I will be still stuck. I will get 50 as the answer. if I want to get the lower bound for 100, I'm getting 50 as the lower bound. So this is not correct. So we need to overwrite the default comparator by giving our own compare function. So I'm going to make a bool compare function that is going to take two numbers a and b, and while finding the lower bound, I'm going to return a number a that is less than equal to my money. Okay, something like this. So let's see. If I give 100 as the money, I get the lower bound as 100, and if I give something greater than 100, let's say 120, then also I should get 100 as the answer. So clearly in both the cases we are getting the correct answer, and we built a compare method that does the work for us. Okay, so now we know what amount of money to subtract. So money is equal to coins of lower bound, and I can say while this money is greater than 0, always found the lower bound, and you print what coin you are picking, cout m, and update money as money equal to money minus m. That's it. So we are making the problem smaller every time by picking a note that is just less than the value of money. Okay, so this will actually show us how we can make the change. Okay, or maybe put a comma here. Let's say 168 it is. So to make a change for 120 rupees, we can say give us 120, or sorry, 150, 10, 5, 2, 1. So this is how you can actually make the change for 168 rupees. Okay, so we made a compare function that actually helps us to get this number that is just lower or equal to the current number. So we have overwritten the functionality of default lower bound function just by adding a compare function. Okay, so that's all for this video, guys. I hope you would now uh, learn this concept of comparators, and you can also use it with binary search. Thanks a lot.